Can you hear me?
Yes.
Good. Good, good. I guess we can start. Well, let's wait till Nikolai comes in. Let's wait till he comes in. In the meantime, I'll start up my Eclipse. I'll get that going. I might as well share my screen. Why not? Share my screen. And we'll start a video. Oh, I forgot something here. Yep. Okay.
Hello, Professor.
Morning. Why is it right now the phone's got a ring? Start the video. Okay, we got that. Do we have that? Oh, I got the wrong one. Wrong video input. We need this guy. Yeah, there it is. Okay, so now I've got my screen shared. And I've got some things to do. Okay, polynomial solution. I got 4 things I want to go over today. It'll be a fun class, I think. Not so much in terms of heavy duty theory. We'll do a little bit of theory for chapter 13 next class on Thursday. But we're just going to have some fun. Today we'll be going over the solution of the polynomial program, and then we're going to do some GUIs, graphical user interfaces. And so let's start that Eclipse going. Okay, I thought I started it. And let's see, baby. Eclipse. Eclipse. Okay, started in the wrong screen. Okay, now it is. There it is, right there. Okay, let's see. Public polynomial solution right there. Now you have this source code. You do have this source code. There's a link to it in, I guess, chapter 11. And there's the driver, which we don't need to talk about that. We know about that. The polynomial right there. This is what we'll talk about, the polynomial. And so pretty much I provide you with some getters, the get degrees, to set, get degrees, set coefficient, get coefficient. I gave you all that stuff here. And then term mult, I gave you as an example of how to process polynomials. But if you go ahead and you take a look at this assignment, it wasn't all that involved if you just give it a chance. And like the addition, okay? You have an addition over here where basically what you're doing, and you got to understand the syntax of this. You're saying A dot add B. That's basically what the main program is going to do to run this add method. Okay, add is a method that's being applied to A. So when you run this method, this is the A polynomial. Okay, now without question, the B polynomial comes in as a parameter there. And so if you think about it, all you got to do, because a lot of this work is done with the get coefficient and the set coefficient. You don't need to do any advanced work here. Okay, what you're going to do is you're going to find the maximum degree of the 2 polynomials, because if you have an x to the 4th term polynomial, and then you have an x squared polynomial, the addition is going to be an x to the 4th polynomial. Okay, now if you ask for a coefficient from the smaller polynomial that just doesn't exist. I mean, if you have an x squared, there is not going to be an x to the 4th polynomial. But if I ask for the x to the 4th polynomial, it'll just return 0. Okay, it'll just return 0. That get coefficient method will return 0 for a non-existing polynomial. Okay, look at this. Just take a look at this. Okay, you're only going to return a coefficient if n, what comes in, is between 0 and the degree. Otherwise, you're going to return 0 right there. So that's what this is going to do. So all you got to do is start from the end, work downwards, and you don't need to start from the end and work downwards. You can go from the bottom up. It's just that it's more efficient on the set coefficient, okay, to just allocate space once Okay, because if you start from the top, you have an x to the fourth term. It immediately what happens is it'll allocate enough space for five coefficients. If you start from the bottom up, okay, like you start from the zero degree. So then what it's going to do is allocate space for one number. Then you ask for the x term. That means you need two numbers. If you look at this logic here, you've got to make the array bigger. So you got to go through all this logic in order to make the array bigger to accommodate the additional coefficient. So if you do it once with the high term, you don't have to do all that allocation. So what you're going to do is you're going to go ahead and grab the ith coefficients, add them, and take that number that I've highlighted and assign it to the ith exponent, the ith coefficient, do that, and then return that addition. Done. Nice and clean, very small code. Now, some people didn't really see. I held it against them slightly. I guess I took a point out for not seeing the beauty of what this would do. Okay, because they had pages. They had pages of code. You know, and it might even have worked. It's just that even a page of code, even if it works, is not as efficient as what you see in about 6 lines. You can't tell me that it's going to be more efficient. So that's it for that. Now this guy, the negative, is another one you're going to do, and that's basically saying a dot negative. Okay, no parameter. You don't need to because negative is being applied to a, and you want to make a the negative. Okay, and so what you're going to do, pretty much the same pattern here. You create a whole new polynomial that's going to be returned. I love this var. Okay, you should love it too. Okay, because if you hover over it, if you hover over negative is a polynomial. See, Eclipse understands that because if you're assigning a polynomial, of course, a negative is going to be a polynomial. There's no need for you to reiterate that it's a polynomial. Although what I have there, 85, but that is fine. So I'm going to go back to var. That's the modern programming. That's basically my thing. They do this in all languages now. Okay, so that's modern coding. The one issue I have with this is if you have to program to a older environment. So say you have an environment that the people that are running, they have to run Java 8. Okay, your code isn't going to work in Java 8 because you're using something that doesn't exist in Java 8. So if you need to program to Java 8, then you're going to have to use Poly. Okay, so that's something that you need to understand. But if you're not worried about, you know, living in the past, yeah, use the var, not a problem. But it's basically the same thing right here. Look at this. Look at this. We're starting from the high exponent down to 0. And we're just going to take coefficient, grab that coefficient, and negate it. Put a minus in front of it. A lot of people did this, which I guess still works. It still works. Actually, -1. -1. They did a lot of that. It still works. But I think they did that only because they didn't understand that all you need to do is put a minus and that negates it. So, you know, do things clean, short, sweet. And so then you're going to return the negative right there. Questions? Any let's see what we got here. Let's see what we got here. We got a bunch of people. Okay. Let's see, only 6 people. They must be outside trying to salt their sidewalks. Okay. All right. Now subtraction. Okay. Now look how short. One-liner. You can't get any better than a one-liner. A dot sub B. That's what you're trying to mimic. Okay. Isn't that basically said? Isn't A minus B simply equal to A plus a negative B? Okay. Using your basic math skills. Okay. We already know how to add. We know how to take the negative of something. And look at what we got here. Okay, remember, A is this. Dot add, take P2, the second polynomial coming in through the parameters, and let's see, add the negative. That's it, and that whole thing just returns a minus b. I think that's sweet. I think that's real sweet. Okay, one line. Okay, that's good. Negative. Evaluate. I took one or the other. One guy actually gave me this type of solution with this better evaluate is much more efficient than this. But when you evaluate, okay, what you're going to do is you're going to pass in a number and you're going to say basically, what's that? Okay, here's what you're going to do. A dot evaluate, and you pass in some number to evaluate x. And this is going to return a double. You're going to take that x and dump it into the polynomial, and this is straightforward. This is the straightforward way to do this. Okay, we're going to go ahead and take the power of x to the fourth or whatever, times the coefficient, whatever that is, the ith coefficient, and add that to the answer. Okay, and then what you're going to have, you do that for every problem. It'll work. It's basically it'll function. This guy's slow. This guy's very slow, but so if you like speed, I want you to investigate how this is much better in terms of speed. There is no x to the power. The whole idea is if I go ahead and say 3x squared plus 5x minus 6. Say we want to do that. Okay, what you're going to do now, let's see if I can remember how to explain this. Okay, I read in the 3. Okay, then in the next iteration, I'm going to multiply that by x and then add the 5. So that's add the 5. Okay, that's the first iteration. And then what I'm going to do is multiply that quantity by x, where I'm going to subtract the 6. Okay, so I'm starting out from the highest exponent and working out, doing these repeated multiplications to build the bigger power. So this is what this code does. All right, and so that's faster than this, but I took both. Doesn't really matter. And this guy right here, I like the idea. What some people did was, I have a lot of logic, a 2-string. You want to print out the polynomial. Okay, you want to print out the polynomial. And I like the idea that they were using string buffers. Okay, and your string buffers automatically build, adjust themselves to more. If you add more and more characters to them, they increase their size automatically. Okay, and the idea is I go from every term. Okay, first off, if the degree is -1, meaning you got no polynomial, don't go through all this aggravation. Okay, there's a lot. This is tiring just to look at. Okay, so just return 0 and be done with it. But if you've got a normal term, what you're going to do is you're going to output the first term right here. Output that first term, which basically means the plus and minus will automatically be added to the first term. The first term is going to exist. If it was a power of 2, x squared term, you're going to print that out with the negative sign. Now, what's going to happen here is I go through the rest of the terms going down, and the idea is, listen, grab the coefficient. If it's equal to 0, you don't want to output that term. You don't want to write down 0x cubed. That doesn't look right. No term if it's 0. Continue just basically is a go-to statement that goes ahead. You don't really need a go-to. And I don't really use continue all that much. But in this case, I thought that was neat. Continue just means go to the end of the loop, bypass all this code. But stay in the loop, but go all the way to the end. Go to the next term, and basically find the next non-zero term. Okay, go ahead and if the coefficient is plus, add a plus sign. Otherwise, add the minus sign, change that term coefficient to a minus, and what you're going to do is output that term. And this guy right here is basically saying that's going to check for if the coefficient is 1. If this coefficient is 1, you're not going to print out 1. Okay, it's going to print out, and also x to the 1. You're not going to write x to the 1. No textbook writes x to the 1. You're going to write down x. So let's see. You're going to go through this logic. If you want to study it, that's good. Let me go ahead and run that. Go to polynomial. I'll show you that does work. And you come over here. Let's see. Order the polynomial. Let's try 3. 3, -5, 6, 7. Okay, that's good. X, I need another one. -2. Oh. Well, I think I screwed up. I didn't need that -2. I didn't need that -2. But take these first 4. Yeah, -3.00. Oh, that's negative. Ah, damn it. Right there. -3x cubed, -5, x, no 1, plus 7. Okay, the problem was that I added another number, which caused us to go to the next input. There you go. That's all I was looking for. Not that difficult, really. Okay, so you have that code, study it, be one with it. So that's the first thing we're going to do today. Now, let's go back to rational numbers. Now, this rational number is your basis for the complex number. Okay, so come over here, rational numbers. Rational numbers, I just want to revisit it a little bit. I really want to talk about this implements, a little bit more detail, because that's really chapter 13 material right there. And this extends object, every class, this is not necessary. Rational is a class, and every class you define already extends object by default. You automatically inherit a bunch of stuff from that object class. The only class that doesn't inherit from anything is object. That's the root of all classes. Okay, so you can write that. You don't need to have that extends object. And let's see, comparable. Now let me hover over this. Hover over this, and let me. I think if I hit F1, if I hit F1, yeah. If you hit F1, you get the Java doc for comparable to show you what that really means. Okay. Comparable is an interface. Okay, an interface is not a class. An interface basically lists all the methods that the class must implement. It's as simple as that. And, if a class implements, and that's what you're doing here, you're implementing an interface. You're telling the compiler to check to make sure that inside that class, I've implemented all the methods that are listed in the interface. There's no code. Although modern Java has code, but the classic interface, and I'm not going to hold you to that, the modern. The standard definition of an interface is that an interface just lists the methods that the class must implement. And so what are those methods? And you can read all that. One, that's all you got to do is implement this one method right there. And that says it's got to be called compared to. It's got to be, what gets passed here is the same, what gets passed there is a rational. That's what that is. This is called a generic. It's a rational. So where'd it go? I lost my, oh. How did I get that? I lost it. Oh, damn. I lost it. I don't know. Let's go back here. Comparable. Comparable Java. Okay, Java 8, same thing. It's okay, it doesn't really matter. Interface comparable. And so T represents the data type that you want to compare to. And it's still the same. I actually like this old version better. Okay, compared to this, compared to is inside the rational. You're comparing the current object with another rational number that you pass into it, and then it returns a number, an integer. That's all you have to do. Okay. Now you can go ahead and read all that stuff if you want, but I guess I get paid the big dollars to explain all that stuff. So that's what I'm going to do. And let's go over here. Let's get rid of this help. It wasn't much of a help. Let's make it bigger. Now, let me show you something. You went out of your way to implement comparable. Okay, you put that in there. And I'm going to delete this. Delete that code. Cut. Okay, just cut it out. Watch what happens. Rational. You get an error. Okay, rational must implement inherited abstract method. Basically, it says rational must implement this. You went out of your way to go ahead and say that this class must implement this comparable interface. And the compiler just said, okay, where's the compare to? Where's the compare to? So what I'm going to do is I'm going to right click this, quick fix it, add unimplemented methods. And where did it go? Somewhere in there, right there. I put it right there. It said, okay, I'm going to provide you with a stub for you to write your code. Doesn't do what you want, but there's the stuff. So there you go. This is the thing. Let me go back to the original code that I had. Okay, and here's what I do. Like I showed you in the rest of the code, A is equal to this because it's still A dot compare to B. That's what you're implementing here. Let me put this in the comment. And this is the rule that you need to follow. If A is less than B, return a negative number. Okay. If A is equal to B, return 0. And if A is bigger than B, the parameter, return a positive number. And so, you know, I gotta believe you can do fractions. Okay, I gotta believe that. And so all you do is you cross multiply those numbers. This is basically cross multiplication. I store one value in the left-hand side, right-hand side. And if the left-hand side is less than right-hand side, then I return a negative number. Doesn't matter what number the negative. I can have it return negative 1,000 if you want. It doesn't matter. But I wouldn't return negative 1,000 because someone's going to look at the code and say, "What the hell am I doing?" Okay, they're going to question themselves. So if the right hand side is bigger than the left hand, if the left hand side is bigger than the right hand side, I return a positive number. If you get to this point, I return 0. Now, when I wrote that, I said that's good. It does work, but you're going to see a lot of people just do a simple subtraction. When you take a look at code that the people do compare tos, what they do is they say, well, why don't we just do this? Return left-hand side minus right-hand side, and you don't need all this gibberish. Okay, there you go. It's the same thing. If all you care about is negativity, 0 positivity, that does the job a lot quicker, smoother. Okay. And so that's it. That's all this is. Implements. Chapter 13 talks about interfaces in much more detail. We'll talk about them a little bit more next class. And I do want to talk about this equals one more time. Equals is not related to compare to, although compare to, I suppose you could say compare to equals 0, which would prove equality. Equals is a method all in itself, and I just want to go back, and this is still a little bit of chapter 13 that I want to throw in there. This was code that was generated by Eclipse, okay? And even the people that like to use, what's that, IntelliJ has the same cut capabilities where it generates code for you. What you're trying to do here is say a / a dot equals b. And it's supposed to mimic this. And we talked many, many times, you never use double equals when you're talking about objects. Okay? Never use double equals. If my explanation doesn't work well, you know how you find out? You can talk to Nikolai. He can help you out maybe a little bit better. And if he doesn't help you out, then there's always Google. Why can't I double equals objects? And somewhere in the Google sphere, you'll find a good answer for you to understand. Okay? This compares references, pointers. It doesn't compare the contents of the pointers. You always need methods to do that. And so all we're doing, if we go through all this logic, what we're checking here in line 122 is if we're comparing the same object. Okay? If you do something like this, and why you would do that, I'm not quite sure. But you have to check for it in your code. If you say a dot equals a, of course they're equal. So I return true. Don't do anything else. If you decide to pass it null, again, I don't know why. Well, I do. If it's not, if you send it a variable and that variable has a value null in it, then yeah, that would make sense. If it equals a null, a is a real object. Null is nothing. Of course they're not equal. This guy checks to see if their classes are the same. They have to be the same class. If you have a dog and a cat, they are not the equal. Okay, they're not equal. Like dogs and cats aren't the same. So that's all this get class means. Return false. Now, when you get to this point, now now what you have here is something that we're going to get to in chapter 13 a little bit more. The object is this parameter. Object is a generic reference. It's a generic object is a pointer to any object that's in your program. It could be a scanner. It could be a rational number. It could be a dog, whatever you have in your class. Object is just a reference, a generic reference. Even though you know that, even though the main program passes in a rational number, the compiler doesn't know that. So a rational number has a denominator and a numerator field. Okay, and you simply can't allow the compiler. You have to tell the compiler that you know what you're doing. So this object gets what's called casted. That says to the compiler, I'm not creating a new object. That's important to understand. The compiler now interprets OBJ, that OBJ variable, which is generic, into a more concrete object, which is rational. Okay, and then I'm taking that pointer and sending it to another variable called other, which I can call, I guess I can say var. All right, var, that's even shorter. This other is considered a rational. So this is just straight, the pointers, the references get copied. That's all you're doing. You're copying the references. You're not creating a new object. Other is the same pointer as this, is just now the compiler now knows it's a rational, in which case you can go ahead and say other dot denominator. No problem there. Other dot numerator, you can compare the numerators and denominators. Let's see. And now if object comes in as a dog, pretend you had a dog somewhere, you had new dog, and that new dog comes in into your equals. First off, it wouldn't make it there. It wouldn't make it there because the get class wouldn't be the same. Let's pretend we did this. Pretend this didn't exist. If you have a dog and you're telling the compiler to consider it a rational, the compiler at runtime, at runtime, that cast will check to see if it's okay to convert that dog to a rational. Dogs and rationals are not the same. You're going to get a runtime error. But that runtime error won't help here, won't occur here, because I already checked ahead of time to make sure the classes are the same. So, and this is a rational number, so it's got to be a rational. So I want you to stew on that a little bit. So I said that we wouldn't talk about theory too much, and we only talked about maybe a half hour, not even a half hour of theory on this. So, okay, that's what I would do is keep this rational tucked away in your project, because you're going to refer to, when you create your complex number, you're going to refer to it a lot here. The kind of code, the kind of pattern that I use, I want you to use that same pattern to generate your complex number. Questions? Nothing. Okay. No questions. Beautiful. Everything. I got to be professor of the year here. I'm everything I say is gold. Gold. Okay, that's good. All right, fun. Let's have some fun. We're going to do some GUIs. Now, let's go. Rational tester. Remember we did this. We ran this code here. And who wants it? Nobody's going to spend money on this. Okay. Okay, but if you go ahead and say A, enter rational number. Okay, 2/4, and we'll say 3/6. Enter. Hey, yeah. Okay. This is garbage. I don't like it. I don't like it. We're now going to perform a GUI. Okay, GUI. Run this bad boy. Oh, I'm going to spend $1 on this. Look at this. What did I have before? 2/4. 2/4. And even my GeForce experience thinks that this is a game, graphical game. Oh boy, I got to disable that. 2/4 added 3/6. Okay, so 3/6 equals 1/1. That sounds good to me. All right, so what you got there is a GUI with a whole bunch of components. Okay, you could almost picture what your complex number is going to look like. Okay, a complex number is not going to have this division symbol in between these boxes. Okay, you probably have a plus sign or something in there. What we have here is a label. What you see as text here is a label. This is not system.out.println. Those days are gone when you're dealing with GUIs. Okay, this is a label. That label has a text value. Okay, so once you load the label with a text value, and you display it, so be it. Labels are the easiest things to create. They don't do much other than display their text. This is a label right over here. That's a label. That's a label. That's a label. This is a label. That's a bunch. I got a bunch of labels in there. This is a label. The things that you interact with, that you take for granted, okay, in your programming here, these are text fields. These are text fields. These are fields where you go ahead and you're allowed to type in the Declaration of Independence. Okay, you could put as many characters as you want in those text fields. All right, hopefully you won't type the Declaration of Independence, okay, because it's tiresome. You're going to put in real numbers. We're going to check for that too. So basically what I'm trying to do is mimic a fraction. I could probably do a better job of doing this, but for now, this is the simplest way I'm going to display the fraction. In reality, I probably would have written this as a text box with a line on the bottom with another text box. You could do that. We will do stuff like that. But when we get to that point, we'll worry about the fanciness of the GUI. But right now, this is still miles better than the previous character-based thing that we had. So for now, we're just going to, I want you to do something like this with your complex number. Okay, so 2 divided by 4, and then we have a little drop down. They call that a combo box. And that combo box has a bunch of items in there. Add, subtract, multiply, divide. You can read the rest, all those operations. And those are all the operations I had in the text, in the character-based program, but it's just, are all there, ready to be, see if I subtract those two fractions, I hit, yeah, 0/1. Look at that. Beautiful. All right. So we got those text fields. This button right here, that's a button. I can put whatever text I want in there. All right. But when you click it, stuff happens. An event occurs. And basically, whenever you click a button, what you're telling the system is to execute a method that looks at these text fields, and underneath you already have that. This rational code is the same code used by this guy and your GUIs and the GUIs. It's exactly the same. So underneath, you're basically using the same logic. That's what you got to appreciate. You're using the same logic. But that's what people do often. Usually they write a command line program just to test out the functionality of the rational number that you want to mimic. Okay. So what you're going to do then, and then once you prove that works, then you go ahead and build the GUI that will call it. And we're going to take a look at the code right now. Let me make this bigger right now. Let's make this bigger. Okay. Right there. So I guess we're ready. We're ready. Let's take a look at the code. Okay, let's put this on the side. I'll refer to it a bit later. Public class. This is what you need to do. You got to name your class appropriately, and people are doing that. That's good. Okay, but it must extend application. It must do that. Your application, your rational tester GUI, is going to inherit from code that was written by Oracle to make it pop up, to make it look like a window. You're inheriting a lot of code from the parent to do this. Okay, so you must bring that in. All right. And so let's go to the end. Let me just go right to the end and say, well, let's also push this up a little bit. You don't need to include a main method, although you need to, if you need to run it from Eclipse. You need to have, I think Eclipse is hardwired to find a main method. So basically you would just copy this and put that into your class. But launch is going to, this is the method that needs to be implemented right there. That's the method that needs to be implemented. And so the first thing I do here is to set up your GUI. This is setup GUI. Don't worry about it. We're going to talk about it. Basically, the pro function behind setup GUI is to lay out your components. It's responsible for creating the text boxes. The problem is, look at how long this is. Okay, it's pretty long because that's what GUI programs are much more detailed. You got to go ahead and you got to take a look at this. You got to create new text fields for everything you intend to use in your program. You got to create the components. And it's not enough just to create the components. Those components need to be laid out into a container called a pane. Panes are containers that hold components. And these panes usually have what are called layouts associated with them. And I'm going to talk about that in a second. So as far as we're concerned, okay, this is the basic idea behind starting your GUI. You will lay out your components. Okay, there's a thing called a scene that needs to be created that takes out your components. It's called a border pane, and a border pane is a special layout, which I'm going to talk about in a second. Okay, but this is basically a pane. Remember, panes hold components, and panes hold components. But border pane lays out those components in a certain way. The scene takes your pane, and that scene has associated with it a width and a height. Okay, let's bring this back. This has a certain width and a certain height. Okay, so it's long width-wise. I established that up here. App width is 1,000. App height's 180. Now, why did I pick those numbers? It's pretty much hit or miss. It's pretty much hit or miss. If I make it too small, Let's see what happens here. If I make it too small, close it. Let's make it say 600 pixels. Make that. Run that. Let's go ahead and run that version. Look at that. That doesn't look right. That doesn't look right. Okay. So through trial and error, okay, 1,000 seem to work out better. And you get this. You get that look. That looks a little bit better. It's trial and error for now. That's just the easiest way to approach this. Okay, so go back to the bottom. Go back all the way to the bottom. So now we've got our scene that takes your GUI with a certain height. Set the title. Okay, what happens is start method gets a window object. Okay, it automatically creates a window object, and that window object gets set to start. What am I talking about? The windows that you take for granted. This is a window, but the problem is Java is Oracle. Oracle window. The word window has to do with Microsoft, and you can't. Microsoft isn't going to let another company use their terms. So what they said was, we'll call this a stage because you're presenting a bunch of actors on a stage inside your inside that window. So this guy here is the title. Rational GUI app, and let's kill that. Start it over again because I changed it. Yeah, there it is. That's better. Okay, that's the title. You should give it a nice title. Okay, maybe when you do this, you can put your name in there too. Okay, all you got to do in this template is put your name in it, maybe by A.C. Silvestri. Put that in there. All right, so then the title of your window will be decorated by your name. Okay. I also took that title and put it inside the app itself, inside the scene. Okay, so let me move this over here. Come down here. Set the title. The window is going to have that scene. I decided the set resizable. Okay, see the false. See, in other words, I can't take this window and make it bigger. I can't make it smaller. That's where this comes in. If I set it to true, then what you're going to get is something that, okay, even the window looks a little bit different. Look, I got that little thing here. See, if you set it to true, oh, I was surprised. I thought they were smushed together. Okay, well, you get this garbage. Look at this. You get something that just doesn't look right. Okay, so to prevent people from doing stuff that you didn't intend to do, what I'm going to do is say, well, don't let them resize it. After 1,000, that's still going to resize it. So set resizable to false. And even all that, you did all that work. When I go to run it, again, if you don't show your window, nothing gets displayed. Nothing gets displayed. So the last thing is you show your window. Okay, and then you come over here, and then it displays nicely. This is pretty much like a little boilerplate of what you're going to use. This is like a template. You know how I gave you that template? People were fighting the template. They hated the template. Okay, that I wanted you to think in terms of the template. Now this is the template that you have to use. Now you may be able to tweak the template here and there, in particular with the sizable. Okay, but this is pretty much, I would just copy all this stuff in and maybe make whatever changes. So right off the bat, I would have 3 constants, 3 finals with height and the title, and put in your program this stuff over here, and then take a break because I don't want to stress you out too much. Relax. Okay, watch a little TV. All right. Next thing I would do is say, before you start programming, what I would probably do is on paper, lay out your components. You know, lay out your components. Basically on paper, what you're going to do is make a little sketch of what you'd like the components to look like and see which components you're going to interact with. Now, what do I mean by that? I'm certainly going to interact with these text fields right there because I'm going to type something in. Interacting basically involves what are components that need to be read or written, read or written, or read or you intend to type something in. All right. Now, certainly these text fields I'm going to interact with. Labels generally are not interactive. Okay, you're not going to change it. If you intend to change this label text, then it's something that you need to encounter. You need to define a variable that's sort of global. Right here, this is what I mean. These are the next thing I would do is define components that you want to interact with by reading, writing, or both. These fields right here, in a sense, are global. They're available throughout the class. And if they're global, then all your methods that you define in here will have access to those fields. They're basically fields that you have in the race car or the rational, the numerator and denominator. These are fields you intend to interact with. Don't put labels in there unless you intend to change the label color to red or something. That might not be a bad idea. I mean, the label, if the label was red, you could indicate that as an error. All right. Now, how am I handling errors? Here, right there. These are certainly not that. These two numbers. This is not a fraction. Okay. I'll put the word error in there, and I probably should have made that bigger. But we can fix that text field a little bit bigger. That's how we're handling our errors. So what I have here are all the components I wanted to interact with. All right. I have 6 text fields. And notice the way I'm defining them. TF, text field. Because when you're writing your code, it's hard to remember. With all these different kind of components, it's hard to remember what kind of component you're dealing with. If I called it X, X is, I don't know, is X a text field? It's just easier to say text field A numerator, text field A denominator. That's basically a naming convention that even Java uses of some sort. Combo box operation is the combo box. I have to show you that. This is a combo box of a class. I'm going to show you what that means, and you're going to like that. You're going to appreciate the toString. Okay, you're going to appreciate the toString when I talk about that class. And then I got myself a little button calculate. All right, button calculate. All right, good. Okay, so here's the brunt of the work is set up GUI. Right there. Private, makes a private method. Set up GUI. It returns a border pane. Right here. Let me just show you what a border pane is. It's actually. Let me come over here. Type in a border pane. And let me just show you. Where'd it go? Oh. Hold on. Let me go ahead and put the video. Okie camera. Okay, I see it right there. Okay, so say we have some real estate, a window. Okay, we have a window. A border pane has 5 regions. You have the north, south, east, and west. The middle part is the center. Okay. So what happens is I've got 5 regions where I can lay out controls. I can lay out panels. Okay. Each of these regions in turn can have a panel in itself. All right. So if I come over here, I can show you what toward the end here. Yeah. Set center, set bottom. Oh my God, I'm using old school. This is the bottom. Bottom, top. This was, I don't know why it said north, south, east, west. I thought that was, I'm thinking of old school swing components. Okay. This is a right and left. And the center is still center. So the idea here is if you take a look at this, I create a border pane. All right, I basically put something in the center, I put something in the bottom. I don't put anything on the top, I don't put anything on the left and right. And if I don't put anything in the left and right, what happens is this real estate here just doesn't exist. The center occupies all that space. The top, if I don't put anything in the top, which you'll see I don't have any set tops or set bottoms or anything, this real estate just occupies. So the center takes up all this space, but I did put something on the bottom, so this real estate gets occupied by the thing that I put on the bottom. Okay, it takes some getting used to, but you will get used to it. It's not that involved. Okay, so let's come back here. Let's show you what we're doing. Okay, for now, setting up GUIs are a pain in the neck, but that's what you're used to when you buy your apps. You like all that prettiness, but they take a lot of work on the part of the developer. Okay, so let's come back here with the camera. For now, just accept, basically I want to set the default weight of the text. Okay, the text that's going to be displayed inside the GUI. I want the text to be bold. I want the text to have a 14-point size. And you just don't memorize all this stuff here. You will use it little by little. You'll acclimate to it. But this is how you define your boldness and your size right here. But all in all, I'll put all that definition inside this constant called component style, ready to be used. In fact, take that component size, of that border pane, set the style to be that. And but what that means is all the subcomponents, all the panes are going to inherit that size. Okay, unless you decide to override it yourself. If an individual component overrides it, okay, then you're going to use the override of that. So here's what I'm talking about. If I go to run this entire scene right here, this entire pane, okay, is got a bold setting with 14 points. So 14-point size is pretty much the same, but this is a little bit smaller. This is a little bit smaller. That's because I made the size for 12-point. Okay, so I overrode the default that every component gets. In fact, I don't even believe I need this. I don't even need that. Okay, I want everything in my app to be bold. Okay, you're going to get that. And just worry about the, yeah, you get that right there. And just to show it, because it almost looks like the same size. Let's make it 10 point. 10 point, run this bad boy right here. Yeah, that's definitely noticeable now that it's smaller. Okay, it's smaller. Whew, okay, let's go down here. Every component that you intend to interact with needs to be created. You need create a new text field, set it equal to, have this app have a reference to it. This is set preferred width. I would like the width. This is 75 pixels, 75 pixels wide. It's not set width, it's set preferred width. And the reason why it's called set preferred width is that some layouts, some panes might choose to use your 75 or might disregard it entirely and make it wider or make it smaller. So basically it's a suggestion, but the layouts that I have right now are going to use the 75 right there. So this you have to set. Each individual component needs to be set, created and set. B does the same thing. C and D, these are the A, B, C, D. I created the objects. Now, understand, I created the objects, but you're not going to see those objects until you put them into a pane. Okay, and in fact, this guy right here, the last two, okay, I'm typing in my keyboard. I can't change it because I set those to editable, false. Set editable false. And you said, why do I have to call getters and setters? Right? Is that what I said? You put something, all you people that know how to program better than me, why do I got to call them get? How do I call them set? Because this is what they do. Okay, this is what Java does. Setters and getters right there. Okay, so that's why you do this stuff. That's what I'm trying to show you exactly. Okay, then you got this thing operation, which is a combo box, a little bit much more complicated. But what I'm trying to do with my combo box is sort of mimic what I had in the text in the command line. All right. And because I developed classes that recognized A, S, M as codes to do addition, subtraction, multiplication, so I don't have to rewrite and reinvent the wheel. What I want to do is use that same pattern. And so what I'm going to do is make this a combo box of something that looks like this. Another class, rational combo box item. I create an array of these things. Okay, rational combo box item takes that as a parameter. Add. That's the text that gets displayed in the combo box. The combo box is going to call the toString for this guy, and the toString is simply going to return add. But when you select it, what comes back is the value, A. And that's what I'm doing here. Subtract, this is going to return. Multiply, divide, etc. Okay? What you need to do is take those items, this operation, which is the combo box, grab its items, and add to it all those things inside the array. You're going to see this pattern. Get something from the object and add to that something. That's what you're going to do, and set the value of the combo box to be the first one, 0. That's why add comes up. If I made it 2, okay, it's going to by default we do multiply first. Let's see if that's right. Multiply. Okay, multiply. See, this is what you put in there. You decided you want to set the value of the combo box to be the second item. But that doesn't make any sense. Let's make it the 0th item. Go back to that. Oh man, I need a. This is a workout. All right. But luckily, you have this code. You can apply this code for your project. A button. Create a new button. That button has an equals. I put a little space to make it a little bit bigger. But every time you create that button, you click on it. An action. Set the action. What do you want this button to do? I want this button to execute this method right here. This is called a map. This is called a lambda. We're going to get into it in a little bit more detail at the due time. But for now, just understand, when you click a button, this method executes. It's going to read the text boxes. It's going to do all the stuff that the text box that the command line was doing, but only in a better way. Okay, and so there's not much left. Okay, create what's called a flow pane. Now, what's going to have here is a flow pane. This is a flow pane. And what happens with a flow pane is you add things to the flow pane. What do I got here? I set the alignment to center, so all these things are going to be centered inside the pane. All right. The insets are basically the padding. Put some space top, bottom, all around the pane. And so this is the label I create. New label. It's still a new label. Enter. You can see that right there. But you'll notice this is a local variable. This is a local variable. Local variables are only seen by the methods. They're only seen by the methods that you're creating. And they don't need to be global. There's no need to have this label as a global variable because you don't intend to use it as any type of interaction. So I make it a local variable. These are global. These are fields of the class, of your application class. Okay, set the width to be the entire distance, the entire width of the app. So basically, this is a label that's this, and there's space here and there's space here because you centered it. All right, so what we're going to do is, yep, we centered it. Create your A, B, C labels. That's what we're doing here. And now check this out. Center pane. This is the center pane. Okay, center pane, which is a flow. I'm going to grab all the children of the pane. I'm going to add all these components, the instructions, the label A, in this order. Okay, what happens is it lays out this component right here. There's no more room on that line. So then it puts the label A, text field, new label slash right there, another text field. It lays them out. Now let me show you what happens here if I just comment out some stuff here. Let me comment out this. And I'm going to comment this out too for now. Okay, I had all those components in there. If I run this, okay, let me show you what happens. All right, here I had a label that takes up the entire width. All right, and what happens is as I add components, it starts off in the middle. If I added another component, they would be centered. Another component would be centered. What happens, you start off in the middle and it grows outward. Okay, so if I go back to what I had before, all right, uh-oh, I screwed up, I screwed something up. Oh, right here, there it is. Run that. Run that, you go back to what we had before. Okay, I added those components and that was enough room. If I added more components and there wasn't enough space here, it starts another row. That's a flow pane. That's a flow pane right there. And so, okay, the bottom flow pane. Okay, I got to remember what I did here. Hold on. Let's run it again. Come on. All right. I laid out the center. Now I got to do the bottom. I want the bottom to just have one thing in there, which is the title. Okay, I have my flow pane on the bottom. Okay, I basically have some padding top and bottom. See, there's 5 pixels top and bottom, and left and right. I set the font size at 10 point, and I add. This is what you do. You grab the children of the pane right here, and you add to that all the objects that you want to add. I'm only adding one thing. And so then basically what happens is this is one complex pane that gets added to the center, another complex pane that gets added to the bottom, and you're returning it back so that the scene will read all that stuff and lay out your components. We're almost done. Almost done. Okay, now we come back here. Okay, do calculation. You click that button, you hit do calculation runs. Okay, what I'm going to do is I'm going to read the operation that I'd like to deal with. From the operation combo box, I grab its value. Okay, that gives me the item, the 0th item, the 1st item, the 3rd item, whatever. And from that, I have a get value that reads the value of the operation, whether it's A, S, and D. Okay, let me show you what I'm talking about here. Rational combo box item. There's the class. There's the class right there. You'll recognize I had a whole bunch, I created a whole bunch of items, display text, value. Okay, I have my fields in there. When I do a toString, which is something that the GUI is going to do in order to display the item, it just returns the text field. But once I select the get value, I grab the value that's associated with that item. It's beautiful. It's garbage. It's great. So if it's A, look what I do. I grab the text from the text field, get text. From A, the denominator, B, denominator, okay? Whenever you grab the text, you have to convert it to an integer, a number. This is how you do it. I grab those numbers, and then what I do is I start creating rational numbers, okay? I have another class that we talked about last time, which basically performs a binary operation, Okay, so you pass it A, you pass it the rational number, rational B. And so then C comes back as a rational number, which I convert to a string. I convert that to a string and set the text of C and D, break out of that loop, you're done. Okay, unaries, just read the first two. If you want to negate something, okay, let's see, when I want to negate something, 3/5. Negate. I don't need to put anything in there. I can put garbage in there. I'm not reading it. Okay, -3/5. All right. Same deal here. C is a comparison. Let's see, comparison. I forgot what it does. 2/5. 2/5. If I do comparison, compare, equals. I think, geez, I forgot what it did. Oh, it's a positive number. It just returns a positive number. 3/5 is bigger than 2/5, and by the logic that I have in there, a positive number comes back as 5. I didn't really spend too much effort there. Equals, are they equal? Let's see, equal. No, they're not equal. I just use this as a result of this. So basically, when you do a GUI, you grab information from the text fields with get text. You do your operation. You create an object, you convert it to a text, and set that text to one of the fields here. Set to one of the fields. Now, what would happen if I typed in that and I want to do a standard divide? I get the error. All I'm doing is I'm saying I surround that entire piece of code with a try catch block. We're going to learn that in due time, in detail in the due time. If there's ever a problem, you can't, like for instance, you can't take that text. That gibberish cannot be interpreted as an integer per parsing. That's not an integer. So it's just going to throw in an exception. That exception gets caught here, and that's where I put my two text fields there. Error. And that is it, guys. That's it. That is basically it. Now you have this code. Yeah, you have this code. Yeah, you have this code. That's in there. I also have a second version, which it's a little bit more. Let's take a look at the second version. It almost looks like the same, where I lay out the components in a different way. I also have a couple of other buttons here. Reset clears the buttons. That's a nice set. That's a nice addition. If you don't want to go through and hit the X button, you can close it. Okay, with that button there. So basically, I expect a couple other error handlers. Where are the other error handlers? Reset app. Close reset app. Where's reset app? Oh, reset app's right there. Okay. You want to reset the app? Click that button. Set all the fields to nothing. Set the value of the operation to the default 0th element. And set request focus basically means, here, when I run this, this is the focus. That component has the focus. So the keyboard, any interaction will deal with that guy there. Now, if I go ahead and I type in 4, that's the focus, 5, got the focus. If I reset, that's the text field that's going to have the focus. If I didn't put that in there, this would have the focus, and that just doesn't look right. Okay, you want to reset it to the beginning, to what it looks like when you start the application. You might want to take a look at that if you wanted to a little bit more sophisticated GUI. I believe I also used another layout that see, it almost looks the same. It almost looks the same. A horizontal box as opposed to a flow pane. Okay, and a horizontal box. This is it almost looks like a flow pane, but the difference is flow panes automatically go onto and create a new line. This is one horizontal box. I put an equals on its own horizontal box. I put these components on a third horizontal box. And then what I do is I take all those horizontal boxes and guess what I do? I put them in a vertical box right there. And with 10 spaces in between each horizontal box. I add all those horizontal boxes to a vertical box. And then I take that vertical box and I believe I put it center pane. Yeah, I put it in the center. Give it a try. This is fun stuff. This is fun stuff. Just go ahead and take a look at it, experiment. Oh, geez, I forgot the most important thing. Okay, I forgot something here. See how there was no errors there? Well, you don't get that for free. Not in GUI world. You don't get it. So what I did was I said, all right, example GUI. You're going to start off. Here's a GUI, right? That looks like a GUI with all sorts of errors. And you're going to want to quit CS entirely because when you look at it, you got all sorts of errors. All right. I made a video on this. I'm going to talk about it right now. I hope people will watch to the end of the video. Okay. What you're going to need to do is include the library that includes all the Java FX. That doesn't come in automatically. So what you're going to do is right click here on the project, properties, build path, Java build path, here, module path, add library. It's going to be a user library. Now, I created the Java FX user library on my machine. Pretend you don't see this. Pretend you don't see this. All right. If you don't see it, click user libraries, new. I'm going to call this Tony's, Tony, in case the apostrophe doesn't work, Tony Java FX. Don't click any of the buttons. Go ahead and do that. Add external jars to this. Okay. You're going to drill down into you know how we have this portable environment? You're going to, this came up automatically because I was fooling around with this before I started this. You're probably going to be in a certain directory. You're going to drill down, okay? You're going to drill down to Java FX SDK library, and then you're going to select all those jar files. Okay, apply, close, finish. Apply, apply, close. All the errors go away. Yay. Now, the nice thing is you only have to do that once. Creating that jar, user library only has to be done once. That's a good thing. Okay, now you go to run it. What the hell is this? What's it? Run it, run. The hell is that? Oh, right there. You gotta select the test. Run. And you get this error. Okay. Oh my God. Life stinks. You got this error. We can compile, we can't run. That's where you need to go into your run configuration. This you have to do for every GUI that you do. This is what you have to do. Go to your run configuration. Okay, project is example. See, these are all your run configurations. Make sure you select the right project, the right test. Test is the program. Arguments, you got to fill in your VM arguments. Now, what do you put in there? Well, here's what you do. I think if you go inside, okay, let's go here. I have those arguments. I also put them on the. I also put those arguments as inside Blackboard, but it's easier for me to go here. Go into your configuration. Right there, your portable environment, right here. VM arguments.txt. Open that up. Okay, open that up. Copy this. Copy, copy. No, I don't want to save it. Don't save it. What's that here? We'll push them in here. Run. Okay. Okay. It just won't let me quit the class right now. Okay. There. Run configuration. Copy. Paste. Paste. Apply. Run. I didn't hit apply. Okay, all I'm doing is I'm putting a circle and positioning it over there. That's all I did, just to get this on. You only have to create the user library once. Good. But anytime you have a GUI, you have to add your VM arguments. But that's it. Once you add your VM arguments, you're done. But every GUI needs to have VM arguments added. Well, what do you think? Huh? It is what it is. What are you going to do? You chose this. You chose this field. Okay. You better like it. This is going to be your life. All right. Otherwise, be a lawyer with the other 1,000 other lawyers out looking for work. Okay. So, what do you think? Any questions, problems? All right. We'll see you Thursday.
Can you
Yes.
repeat about the library, please? The one that you only make once?
You only make once, right?
Yes.
Were you asleep? Here.
No.
There you go. Go right here. Right click on this. New. Right click. Properties. Build path. Click libraries. Module path. Add library. User library. Pretend you don't see these two. Because if you did see them, you just click them, you're done. You did.
Okay.
Run here. New. Okay, add external jars. Drill down to where JavaFX SDK 15.01 live. Select all those jars. Apply, close, finish, apply, done, and that's it's there. The errors go away. Then you got to worry about the VM arguments separately.
Oh, thank you.
All right. Anything else? All right, Thursday, I'm going to send out an invite right now. Oh, by the way, if it's a 9:30 class, why are you joining like 8:30 or an hour earlier?
I couldn't find the link.
Go ahead, because now I have to edit this thing. I got to edit this video because you start the video, and I got to edit it. It's going to take like an hour to edit out the first half hour of this video. Start 9:30. Find ahead of time. Don't click the link. Find it. All right. We'll see you on 9:30, and we're going to see you Thursday. All right. We'll catch it. Bye.
All right.
Thank
Take
you.
care.